Hello everyone, welcome to episode 14. In this episode, we'll be diving into the Animinstance class we created. First, navigate to your C++ class folder and open the game framework folder. Inside, locate the Metahuman instance and double-click it. Next, open Animinstance.h. This is where we'll be working. I'll walk you through the code step by step, explaining how everything functions within the class. Let's get started. The public access specifier makes these functions accessible from anywhere outside the class. In the context of animation systems, these functions are likely to be called by other parts of the game engine or application. For example, an animation manager or game objects update loop might call native update animation to update the animation every frame. The engine that is running the animation needs to be able to access these functions. By making them public, the class allows other components to interact with and control the animation. If they were private or protected, they would only be accessible within the class itself or within derived classes, respectively, which would severely limit the usefulness in an animation system. The virtual key is crucial in object-oriented programming. It indicates that these functions are intended to be overridden by derived classes. This allows for polymorphism, where objects of different classes can be treated as an object of common base class. When a virtual function is called through a base class, pointer or reference, the actual function that gets executed is determined at runtime based on the object's actual type. Void native initialize animation. This function is designed to handle the initial setup or initialization of an animation. It takes no arguments and returns nothing. Think of it as the place where you set up initial animation states, load animation data, or perform other one-time setup tasks. Void native update animation float delta time. This function is responsible for updating the animation state over time. It takes a float argument named delta time. Delta time represents the time elapsed since the last frame or update. It's essential for frame rate independent animation. If you simply animate based on frames, animations will run faster on faster computers. Using delta time, you can make your animations run at the same speed regardless of the device frame rate. It also returns nothing. This function would typically contain logic to advance the animation's progress, update bone transformations, or modify other animations related properties based on the delta time. Override. The override keyword introduced in C++ 11 is a safety feature It explicitly tells the compiler that the function is intended to override a virtual function from a base class. If the base class doesn't have a virtual function with the same signature, the compiler will produce an error. This helps prevent accidental errors due to typos or incorrect function signatures. In summary, this code defines two virtual functions for managing animation, allowing derived classes to customize animation behavior. The public access specifier ensures that the functions can be called from other parts of the program, enabling external control and interactions with the animation system. Encapsulation, the private access specifier, enforces encapsulation, a fundamental principle of OOP. It means that the variables can only be accessed and modified from within the class itself. Data integrity. By making these variables private, you prevent other parts of the code from accidentally or intentionally changing their values in ways that could lead to bugs or unexpected behavior. Control over access. The class's member functions are responsible for managing these variables. This allows the class to maintain control over its internal state and ensure that the variables are always in a valid state. Reduce coupling. Making the variable private reduces the coupling between different parts of the code. Other classes don't need to know about the internal details of how this class stores this data. Allow private access equals true. Exception. While private variables are normally restricted, the meta equals allow private access equals true. uProperty metadata specifically allows blueprints access for reading. This is a controlled exception, often used to expose necessary data to blueprints without fully making the variable public. uProperty. This is a macro specific to Unreal Engine. It's used to expose variables to the Unreal Engine reflection system, allowing them to be used in the editor and in blueprints. Blueprint read-only. This specifies that the variable can be read from blueprints but not modified. This is important for preventing unintended changes to internal data. Category equal movement. This organizes the variable within the blueprint editor, placing it in the category labeled movement for better organization. Meta equals allow private access equals true. This is a crucial metadata flag. It allows blueprints to read this private variable. Without this, even blueprint read only would not function. Float speed. This declares a floating point variable named speed. It represents the character's movement speed. Bool b as in air. This declares a Boolean variable named b as in air. The b prefix is a common convention in UE4 and UE5 to indicate a Boolean true and false value. It likely represents whether the character is currently in the air, jumping, or falling. Bool b is accelerating. Similar to the previous line, this declares a Boolean variable named b is accelerating. It represents whether the character is currently accelerating, i.e. holding down a sprint button. Now we're going to add uFunction blueprint callable to our function native update animation. This macro makes the function callable from blueprints. It allows game designers to use the function in Unreal Engine's blueprint scripting system without writing C++ code. Example use case: a designer could call native update animation manually from blueprints to trigger an update. Now take time to pause and copy the code. Now let's create code for our source code file. Let's start with our header files. Animinstance.h. This is the header file where the Metahuman class is declared. Game framework / character movement component.h. This provides access to movement related data such as velocity and acceleration. Game framework / pawn.h. This allows interaction with the pawn, the actor controlled by the player or AI. Explanation of the code. This code defines the native initialize animation function inside a uMetaInstance class, which is a subclass of Unreal Engine's Animinstance, used to handle animations for a character or object. Line by line breakdown. Void uMetaInstance native initialize animation. This function is an override of Unreal Engine's built-in native initialize animation function. It's automatically called when the animation instance is created, when the game starts, or when an animation instance is assigned to a character. Super native initialize animation. This calls the parent's class native initialize animation function to ensure any built-in initialization logic from Animinstance is executed first. If a pawn pointed at owning pawn equals try get pawn owner. Try get pawn owner is a built-in Unreal function that gets the pawn, character or object, that owns this animation instance. The result is stored in owning pawn, but only if it's a valid, i.e. not null pointer. If owning pawn is valid, this block is where we can add extra custom initialization logic, like getting character specific properties for animations. What does this code do? It runs when the animation instance is first created. It gets the pawn that owns the animation instance, like the player's character. Right now, the block is empty, but you can use it to set up character specific animation properties. Now let's move on to the next line of code. The purpose of this function. The function is part of the animation system in Unreal Engine. It's used to update animation related values like speed, whether a character is in the air, etc. every frame, based on what the game character is currently doing. It lives inside an animation blueprint C++ class, a subclass of Animinstance. In this case, is part of a custom animation class called uMetaAnimInstance. Now let's break the code down. uMetaAnimInstance native update animation float delta time. This is a virtual function called every frame by the animation system. Delta time is the time in seconds since the last frame. useful for time-based calculations, not directly used here, but passed in just in case. Animinstance is the custom animation class we're working with. Super Native Update Animation Delta Time. This calls the parent version of Native Update Animation from Animinstance. It's good practice to call the base class function so Unreal Engine can do its own internal animation updates. If a pawn pointed at owning pawn equals try get pawn owner, this tries to get the pawn, player or NPC that this animation blueprint is controlling. Try get pawn owner returns a pointer to the pawn like the character model. If successful, we can now access the pawn's properties like movement. If uCharacter movement component pointed at movement component equals cast uCharacter movement component owning pawn pass into get movement component. Every character has a movement component which handles walking, jumping, falling, etc. We get the component here. Cast uCharacter movement component is used because get movement component returns a more general type. We're casting it to a more specific type to use character specific movement functions. Speed equals movement component passed into velocity dot size. This line calculates how fast the character is moving. Velocity is a 3D vector showing direction and speed. Dot size gives us the magnitude, i.e. how fast the character is going. This value is usually used in a blend space or animation graph to blend between idle, walk, run animations. B is in air equals movement component passed into is falling. This checks if the character is currently in the air, falling, jumping, etc. Returns true if the character is not grounded. Useful for switching to jump or fall animations. V is accelerating equals movement component passed into get current acceleration dot size 0.0 float. This checks if the character is currently accelerating, trying to speed up or change direction. If the size of the acceleration vector is greater than 0, it means the player is pressing movement input. Helps decide when to trigger animations like start and stop movement transitions. Else speed equals 0.0f, which is float. B is in air equals false. B is accelerating equals false. If the pawn couldn't be found, for example, in the first frame before the animation system has initialized, we reset all variables to safe default values. Summary of what the function does. Every frame, it checks what character, pawn, this animation belongs to. If the character exists, get how fast it's moving, speed. Check if it's in the air, B is in air. See if it's accelerating, B is accelerating. These values are typically used inside an animation blueprint to control blending between different animations. Now take time to copy the code. It's more zoomed in so you'll be able to see the code more clearly. Some of the code is going to be scrolled through, so take your time and pause. Now that you've copied the code, we're going to build our solution. Go up to build and scroll down till you see build Metahuman RPG and build. Now if you have your Unreal editor open, close it, and we're gonna go up to this transparent arrow, start without debugging, and we're gonna press this. Now that we're in the Unreal editor, what we need to do now is navigate to our all, and in the all we'll go to our content folder, and then we'll go to our Metahuman RPG folder, then our characters folder, then our animation folder, and we're going to start with the Meta Warrior APB, and I'm going to explain how to integrate your Animinstance instance in here. So what you do is you right click and we'll search our native update instance. Alright, and this is our call function for our C++ code. And the way we will use this in here is we will just drag this out and plug this in like that and plug it in right there and hook that delta time in there, and this is how you would use your native update animation. But since we're not going to use that right now, I'm going to delete it, and we're going to hook this back up. And the next thing I need to show you is when we go to our anim graph and we go to our locomotion. Oh, wrong one. And go our walk run, and we have our ground speed here. Let's see if I can go in here, and it shows the inherited. Well, we'll just go and search our speed, and you'll see that the speed that we made for our C++ is here under movement. We can get speed and you can just hook that into there, but like I said, we're not going to use this stuff right now. And then we'll have is in air. It's under our movement, just like that. We have our is in air, and we have our is accelerating. So that's how you would call it in and hook it up to your stuff. But like I said, we're not going to use that right now. This is just an example of how to access this stuff. So this completes our Animinstance tutorial. So thank you guys for watching, and I will see you next time. And check the description to see all my socials and see other information that you might want to know.